Hello, welcome to our next lecture on integral calculus. What we are going to do in this lecture is we are going to move to integration by substitution. Okay, so this is our lecture 3. We are going to do integration by substitution. In our previous lecture, what we had done was we had done basics of integration, that is we did with the formulas, and then we had also done a simple integration like addition and then multiplication of two algebraic terms. Then we did e power x type of questions. In this lecture we are going to do integration by substitution. Okay, so what kind of questions we will be doing under this? We are going to do basically question number 9, 11, 21 and 48. Okay. I'm covering all the questions in the exercise on integration by substitution. I'm not going to give you any self-practice problems also on this. Okay. For practice, you can practice the example problems under this topic. Now, I keep harping even in the previous lectures that for doing integration, we must be thorough with differentiation. You're going to know why I have been saying that so far in this lecture. Okay, so please take question number 9 in your textbook. Now look at this question. This question is telling you directly that use the method of substitution to evaluate integral x into x square plus 4 whole power 5 dx. Okay, the question is telling you here to use the method of substitution, but all questions may not mention that. But in spite of that, we will have to understand when to use substitution. For example, look at question number 11. Like I told you earlier, I'm going to do question number 9, 11, 21, 24, 48. Let us look at the similarities of these questions. Okay. Now look at question number 9. In question number 9, we see that we have x multiplied with x square plus 4 the whole power 5. I have told you earlier also, in integration, we do not have product rule or we do not have quotient rule. See, this is product of two functions. See, this is division of two functions. So we don't have a quotient rule. We don't have a product rule in integration for us to find the answers. So these are the kind of questions where we are going to use integration by substitution. But some questions may not be solvable by this method also. For that, we will have to learn some advanced techniques like integration by parts or partial fractions, which we will see in the next lecture. Okay, so now look at this. 9th question. We have x into x square plus 4 the whole power 5. Okay, now let me write this question down. Let us continue. Let me write integral x into x square plus 4 the whole power 5 dx. Okay, so now let us look at this question. Have I written it correctly? X into x square plus 4 the whole power 5. Okay, so now come back to the question. Now, when are we going to use integration by substitution? We are going to use integration by substitution when we see product of two functions or division of two functions. Okay. Now, in that also, when we see product or division, one function is the differential of the other function. Okay. Let me repeat. One function is the differential of the other. For example, if this is f of x, this becomes f dash of x. Okay, how? Let me say, let x square plus 4 equal to some term z. Normally, the convention is to use z or to use u. Now, if I say that this term is equal to z, then when I differentiate both sides, okay, now I'm saying differentiating on both sides, then what we get is 2x dx is equal to dz. Okay, so now x dx is equal to dz into half. I have arrived here. Okay, now look at this term x dx. Go back and check in the question if you have this term x dx. Do I have this? Yes, I have x dx. Both I have. Right? So let's go back to the statement we said originally. One term is f of x then the other term is f dash of x. If one term is f of x, the other term is f dash of x. So let us go back and substitute now in the question. Okay. Now when we go back and substitute, carefully substitute in the place of x dx. Instead of x dx, we have to put half dz. Half is a constant, so I'll keep it outside. Instead of x dx, I'm going to put dz. Now instead of x square plus 4, I'm going to put z power 5. Okay. Now all you have is a single algebraic function. Is it possible to integrate now? Yes. It is similar to the basics we have learned in yesterday's class or the previous lecture. So what did we learn there? Z power 5 is nothing but integration of that is z power 6 divided by 6 plus k. Please don't forget we already had a half in the question. I'm just rewriting that. Now let us rewrite this. This is z power 6 divided by 12 plus k. And what was your z originally? This was the value of z. Let us substitute that. It is nothing but x square plus 4 the whole power 6 divided by 12 plus k. Okay. So this is our first question on integration by substitution. Okay. Let us look at the next question. Question number 11. Question number 11, let us take it down. Integrate 8x square divided by x cube plus 2 the whole power 3 dx. Integrate 8x square divided by x cube plus 2 the whole power 3. Let me just check once if I've taken it down correctly. X cube plus 2 the whole square. Okay. Let's come back now. There is a dx. Let's not forget that. Now, like I told you in the previous question, in integration by substitution, one function is, you have one f of x and the other function is f dash of x. Suppose this is your function f of x. The other function is mostly your f dash of x. So this is why you need to check once when you look at the question, slightly mentally you have to just check whether if I differentiate one function, I'll get the other function. For example, here if I say let z cube plus 2, and that also mostly, just one small clue, this is not 100%, I cannot generalize it, but 99% this is true. Whenever the term has a power here, like for example, it has a 3 in this case. In the previous question, there is a power 5 here. So these are the questions we normally substitute, like how we have substituted here. And similarly, here also we substitute. X cube plus 2 is equal to a z. Okay. Now when I differentiate both the sides, I will get 3x square dx is equal to dz. Or rather, earlier how we have learned it, we don't say dx here. What we say is dz by dx. So next step is to write x square dx is equal to 1 by 3 dz. This is how we have learned earlier. So I'm just cross multiplying the terms. Okay. Now go back to the question and see if there is a x square dx. Yes, there is x square dx. Okay. So since you have an x square dx, what you should do is in the place of that, you substitute this value 1 by 3 dz. So let's do that. Integral 8 you keep as it is. This 1 by 3 you just keep it as it is. So it becomes 8 by 3. So what you have left is only x square dx. You have only this x square dx, right? This x So this becomes z cube. Okay. Now we can integrate because it's a single algebraic term. So in the next step, I will write it as 8 by 3 integral z power minus 3 dz, which is nothing but 8 by 3 again as it is, into z power minus 3 plus 1 is minus 3 plus 1 is minus 2 divided by a minus 2. Okay, so now we can cancel this term and this term, so it becomes a 4. So I can write it as minus 4 by 3, and since this has a power negative, we can bring it down to the denominator. It will become a z square. Now what was the value of z square? X cube plus 2. So we can rewrite it minus 4 divided by 3 into x cube plus 2, the whole square. So this is my answer. Don't forget to add a k. Every answer we should add a k. So now let us look at the options and check this. You have it here. Now if you notice, both the options are the same. Okay, that is option A as well as option B, both are same. So I'm going to pick up option B because in option B it is quite clear that this is in the denominator. Here I'm not too clear whether it is in the denominator or it is 4 into. So I'm going to pick it up as option B. This is a positive, so it's definitely not option C. So it is option B. Okay. Come to question number 21. Question number 21 says, you have x power x into 1 plus log x. See, this question I have selected for doing it under integration by substitution. Now, when I was just going through all the questions, I had to scan questions, the ones which would fit under substitution. So in the examination also, when you're looking at the questions in the examination which pertain to integration, you have to scan these questions and think about it in your head. What rule will you apply here? Will you apply substitution? Will you apply parts? Will you apply partial fractions and so on? And how would you do that? You would do that by first practicing your differentiation thoroughly. That is why I'm again and again telling you that differentiation is very, very important. So moment you look at this question, you will know that this has to be done by substitution because we are thorough with differentiation. And how is that? Like I told you, one function is the differentiation of the other. Okay. Suppose I assume this to be f of x and this will be f dash of x. The first two questions, no problem. Question number 9 and question number 11. Both the questions were algebraic questions. And I also gave you a clue in that algebraic question. If there is a power, assume that to be mostly z. Now, what do you do in these kind of questions? Here, always look at this x power x. Okay. Do you remember logarithmic differentiation? We do logarithmic differentiation whenever you have a variable power another variable. So this means that this will be my f of x and this function will be my f dash of x. How? Just look at this. Let x power x equal to z. Okay. Now taking log on both sides. When you take log on both sides, it becomes log x power x is equal to log z. Now the power normally comes out, right? So it becomes x log x equal to log z. Okay. Now I'm going to differentiate on both sides. Now I'm going to differentiate on both sides. So how do we differentiate it? See, this is nothing but the product rule. Function 1, function 2. So keep the first function as it is. First function x as it is. Differentiate the second function log x, which is nothing but 1 upon x, plus log x into differentiation of the first function x is 1. This is equal to log z differentiation is 1 by z into dz by dx. Okay. Now let us simplify this further. What happens is 1. X and x gets cancelled. What you get is a 1. Okay. One plus this x and x is getting cancelled. 1 plus log x is what you have here. Close the bracket. This dx you take it to the other side. What you get is dz by z. Okay. Now look at this and compare the question. Do you see? It is there in the question. That is why we assumed x power x as z, because many of you would get this doubt. Why are you assuming x power x as z and not assuming 1 plus log x as z? Right? So this is the reason, because x power x is f of x and f dash of x is 1 plus log x, and therefore we assume x power x to be z. And how do we get to understand this? Only through practice. Only when we practice a lot of differentiation, this will go into our memory. Okay. Okay, so this is what we have. I'm going to go back in the question and substitute for this whole term. I'm going to substitute it as, okay, along with this, I'm going to take it as dz by, so this whole thing becomes dz by z. So that we can write it here as 1 upon z. Now this term x power x is nothing but a z, so that I'm going to write here. Okay, so both will get cancelled. When I integrate this, all I'm going to get is 1 dz integration, which is nothing but z plus k. And what is z? Z is nothing but x power x plus k is my answer. Okay, so let us look at question number 21. Do I have it in the answers? Yes, option C. Plus C or plus K, both are acceptable. Option D is my answer. Option D. Okay. Now let us go to question number 24. Let's take this question down. Integral e power x plus e power minus x the whole square into e power x minus e power minus x. Integral e power x, the bracket, e power minus x. Is it a plus or a minus in between? I've missed that. Plus and then another minus. Okay. There's a plus here with the whole square, and then e power x minus e power minus x dx. This is what we have in the question. Okay, let's just check once. Yes, we are right. Okay, now again, let me give you 1 or 2 seconds to think about what should be your f of x function and what will be the f dash of x function. So think about it. Differentiation of one function is the other function. Okay, differentiation of one function is the other function. So which is your f of x and which is your f dash of x? Now, another clue that I have given in the first question 9 and the second one 11 is the one with the power, you normally take it as z. Okay, so same thing will be applicable here also. 1 minute. There is no minus outside. I think this has come by mistake. Okay, so now we have e power x plus e power minus x to be z. Now differentiate both sides, you will get e power x. This will also remain as e power minus x. However, this minus in the power will become minus here. Okay, the whole thing into dx is equal to dz, or I can even write, if you want, I can, in this question also I can write it as dz by dx and then cross multiply in the next step. So that is okay. But once you have practiced enough and you feel comfortable, you can straight away write the dx here and the dz here. Okay, so this is what we have here. Now this term entirely becomes dz, isn't it? So now let us substitute it. So let us now continue. We are substituting here e power x minus e power minus x dx. So this is what we are substituting here. Okay, so the whole thing becomes a dz, and this term is nothing but z square. And how do you integrate z square? Z square is nothing but z power 3 divided by 3 plus k. Okay, so now z value is nothing but e power x plus e power minus x the whole power 3 divided by 3 plus k. Okay, so now let us match with the options and see which one matches. This is nothing but option A, and unfortunately there's a printing error in the option A where there is no power negative. I think it's only a printing error. You can check with the options behind. They would have selected A and not D. So in the examination, you can be rest assured the printing errors would not happen in the examination. So for now, I will go with option A but with a negative in the power. Okay. Next question. Question number 48. Okay, so this question, look at this question, question number 48. E power x, I'm going to write this question down. Integral e power x, same thing with the e power, but here it is a multiplication. Question number 48. For the question it was a multiplication. In the 48th question it's a division. Okay, so let us just look at the question again to see where is the plus. The plus is in the denominator and the minus is in the numerator. Dx. Now this is a very tricky thing. Okay, so the differentiation of this would give this and the differentiation of this would give this. So both the functions can be taken as either of the function can be taken as an f of x function, the other one becomes an f dash of x function. However, what we need to understand here is we want dx multiplied by f dash of x. What do we want? We want f dash of x multiplied with dx. Okay, so in this case, if you see, this is in this form, f dash of x into dx divided by f of x. So what is my f of x here? This is my f of x, right? So let me say let e power x plus e power minus x equal to z. Now if I differentiate both the sides, I'll get e power x minus e power minus x is equal to dz by dx. Now this dx, you take it to the left hand side. E power x minus e power minus x, close the bracket, put a dx is equal to dz. Okay, so this is what I have in the numerator. So when I go back and substitute in the numerator, what I would write is this whole term, I would write it as a dz, and denominator, I would write it as z. So anything divided by z, the integration of this becomes log z plus k. And what is my log z? Log of z is nothing but e power x plus e power minus x plus k. Now, when the question matches exactly with this format, which we saw in this case, then we can write the answer as log of f of x. This is a formula that all of you can also make a note of. Okay, this is a formula which you can use in the examination where the question exactly matches. But very rarely the question would exactly match with this format. So that is why I have shown you how to do it by substitution also. Okay, so practice, friends. In the next lecture, we will do integration by parts and then partial fractions. Okay, then we will go to definite integrals and then we will do standard integrals formula. Okay, so please practice up to here very well. See you all in the next video.